Hi, and welcome to our second lesson in Chapter 1. Today we are going to be talking a little bit about relations and functions. We need to start out with a little bit of vocabulary today, and I'd like to ask you to think back, because you've heard these words before. A relation, folks, is simply a set of ordered pairs. So you might think about that as being a set of XY values. That's what most of us will think about. However, it doesn't have to look exactly like that. It could be something like speed versus miles traveled or distance traveled. Okay, ordered pairs. The next of our vocabulary terms is domain. And again, many of you will remember that the domain in a relation it consists of the input values, what we would call the X values usually, because we're all algebra students. The range, on the other hand, is the output values in a relation or function, usually Y. And we've already tossed around the word function because it's hard to do this without saying the word. A function is just a special kind of relation, specifically a relation in which each member of the domain is paired with one and only one member of the range. Folks, that means that each X for us goes with one and only one Y. For every X, there can only be one Y. Okay? Relations can be shown in several ways, and we're going to look at each of them on the next slide. Many of us are familiar with the ordered pair notation. So a listing of ordered pairs. A second way to show a relation is with a table, a graph. The last of our methods is a mapping, and some of you will remember that from your algebra class, and when you look to the next slide you'll remember for sure. We have a mapping right here where this circle represents the domain or input, and the circle on the right is the range. And the question is this relation a function? Does each member of the domain go to exactly one member of the range? And the answer to this one is yes. You don't have any of these domain values going to more than one range member. That's what it takes to be a function. Each X gets exactly one Y. As you look at the graph, some of you will remember the vertical line test to determine if you have a function, and that is draw any vertical line through your graph. If it hits the graph in more than one spot, that's not a function. This is not a function because there are many X values that give off two different Y. As you look at these two examples, I'm going to ask you to stop the video, please. Come up with your idea about whether this is a function or not, and an explanation of why. We'll catch up with you in a minute. You can see my answers to these questions here. On the left in this table, yes, this is a function. Each X has only one Y. There is no repeated X in here, so each X goes with only the Y that it's shown with. In the graph, this is also a function since a vertical line only cuts through the graph in one place. Okay. Our next activity here, we're supposed to do two different things, so I hope this is not confusing to you, but I want you to select Y values that will make this a function. If you would, let's pause the video. You can see my responses again. In order for this to be a function, that X value -5, it has to be with the same number each time. And it is. This repeated X, -3, has to be with the same value each time, and it is. Now I'd like you to do the opposite thing. Select values for this column, Y1, that will not be a function with this X list. Will you stop that video and let's try this? Very good. If we're not a function, that means that those repeated X, or when X shows up twice, it's with a different Y each time, not a function. Good. Let's move on. Our next activity asks us to determine whether the equation that's shown defines Y as a function of X. That is this relation a function? And the simple way to answer this question is to solve for Y. So I'm going to ask you to do that on the left. Solving for y would mean that we subtract 2x from both sides, and y would equal negative 2x plus 6. Folks, that is a line, and if you think about it, if you input any value for x, positive, negative, or 0, okay, only one y will come out. If I put a negative 1 in for x, that's negative 2 times negative 1, which is 2. 2 plus 6 is 8. If I put 0 in for x, that makes that 0, and adding 6, total value 6. If I put 1 in, negative 2 plus 6 is 4. 1x, 1y. This is a function. 1x leads to 1y. On this side, we've got some squared things going on, but the technique is the same. Solve for y. So let's subtract that x squared to the other side. Solving for y means taking the square root on both sides. In fact, since we're introducing the square root symbol, we have to use a plus or minus, and then negative x squared plus 9 is under the radical. I'm going to ask you to do the same kind of thinking. Positive values, negative values, 0. So I'm going to use those same 3, and let's see what happens. Using a negative 1 for x, negative 1 squared is 1. The opposite of 1 is negative 1, so minus 1 plus 9 is 8, and what we have is a positive or negative square root of 8. Right off the bat, right there, 1x produces or goes with 2y's, not a function, okay? Not a function, because 1x goes to 2y's, and it can't happen that way in a function. We want to spend the rest of our time talking about domain and range for functions, and a big part of what we got to think about today is this. I'm going to put a star here because this is important. If we are given an equation and they don't tell you what the domain is, okay, you can figure the domain by following 2 simple rules, okay? You can't have a negative value under a radical. So any x that produces a negative value under the radical is not allowed in the domain. The second rule, you can't have a denominator that evaluates to 0. Can't have a denominator in a fraction that produces 0. Okay. 2 rules that we got to think about. With that in mind, I'm going to ask you to take a look at these, and let's think about what possible domain could be for these functions. This one has a radical, so we're going to look at here. We cannot use any x that will produce a negative value overall under that radical. So as you think about that, if I put negative 2 in here, negative 2 plus 1 is negative 1. That is not allowed. Okay. If, however, I put negative 1 in for x, negative 1 plus 1 is 0, and the square root of 0 is 0. So our domain here consists of all x such that x has to be larger than or equal to negative 1. This is the set builder notation for range. We could also have talked about that using brackets. That is the domain, another way to specify that. If we are including negative 1, we use a square end on the bracket, and then any number larger than that headed toward infinity. Okay, rounded end on this parenthesis because infinity doesn't stop. Square bracket means you've got a stopping place, or you're including that number. Let's look at our second example. And folks, this one does have a fraction, so we're looking at the second rule here. You cannot use an x that will produce a value of 0 under the denominator. So let's take a look at what will make the denominator 0. X squared minus 4x is equal to 0 when? Okay? And you think to yourself, Well, that factors x times x minus 4 equals 0. And once you have it in factored form, x of 0 is going to cause you an issue here. That is, if I put 0 in for x, I would have 0 here minus 0 here, which is still 0, and you cannot have 0 in the denominator of a fraction. So x equals 0 cannot happen. The other parenthesis says that x minus 4, or x equals 4 when you solve it, also produces a problem. 4 squared is 16, minus 4 times 4, that's 16 as well. That will give you a 0. Our domain here is any x except for x of 0 and x of 4. If I were going to write that in the set builder notation, which to me is the easier way, I want all x such that x is not equal to 0 and x is not equal to 4. The last page here on our flip chart is just refreshing us on function notation. We are to evaluate, it says f of negative 3 if f of x is equal to this, x cubed plus 4x minus 6. What that is talking about is use negative 3 in place of x. So we want negative 3 cubed plus 4 times negative 3 minus 6, and do the arithmetic. That's a negative 27 minus 12 minus 6 evaluates to 39, 40, negative 45, if I did the arithmetic right, and I think I did. Okay. Function notation just says use this value in place of x. So wherever x was, we put a negative 3. The next question or activity also has to do with functions. Take a look at the two functions that are shown here. F of x equals 2x and g of x equals 2x minus 6. Before we graph these functions, folks, do you know how they're related? How will the graph of the second be different from the graph of the first? Well, let's find out. I'm going to ask you to pause the video, graph the line. Actually, we're not graphing a line. Instead, we're graphing points, since we're given a domain that does not consist of all the numbers between negative 2 and 2, just the integer numbers. So what we're going to do is use an x of negative 2, negative 1, 0, 1, and 2, figure out a y for the first one of 2x, and for the second one, 2x minus 6. Alright, will you pause the video, plot those points? Thank you. Back, and here are my results. In black, I have the f of x function. I have my table set up and I graphed those points here. In red, I have my table set up and graphed those points here. How is the graph of g of x related to f of x? Well, if you look at it, at each x value, the red graph is 6 units lower from here, 6 units lower than the graph of f of x. So the graph of g of x is 6 units lower. And lastly, today we're going to ask you to decide whether we have a function, then give the domain and range of each relation. It says, because we don't know for sure that they're functions. I'm going to do the first one, and then we'll stop and have you try the other two. Vertical line test. We'll hit that parabola in only one spot. That means that this is a function. Its domain, functions have as their domain all x. So the domain is x such that x is a real number. That E stands for is an element of or belongs to. The range for the first one, well, you gotta look a little closer here. Range goes with y values, and these y's go from negative 4 and above. So the range on this first one is all y such that y is greater than or equal to negative 4. I'm going to ask you to pause the video, do these last two problems, decide if you have a function, give the domain and range. Alright, here are my responses to those questions. The middle graph, yes, this is a function because the vertical line only hits it once. Its domain, Folks, we're only looking at a very small part of it, but this includes all real numbers because it continues going and going and going, never stops. So the domain is x such that x is an element of the real numbers. The range of this function is also all real numbers. That is, it will continue to grow. Slow growth, but continues to grow. The last one, this is not a function because a vertical line hits this graph in two different places, so not a function. However, its domain can be found because domain goes with x's, and the x's here have to be bigger than or equal to -4. The range, those are y values. Again, this one continues to grow and decrease, so all real numbers for y. Good. I hope we've refreshed your memory a little bit. We're going to ask you to get out there and try that U-Try. We'll talk to you about this in school tomorrow.